Recently, very important news has emerged about DARPA agency and Korean fusion reactor. The first news with us says, superfast drone fitted with new rotating detonation rocket engine approaches the speed of sound. Venus Aerospace has completed the inaugural test flight of a drone fitted with its rotating detonation rocket engine, accelerating it to just under the speed of sound. The company wants to one day build superfast commercial jets using this new type of engine, company representatives said in a statement. In the test flight conducted Feb 24, the company flew the drone, which is 2.4 meters long and weighs 136 kilograms, to an altitude of 3658 meters by an Aero L-29 Dolphin plane before it was deployed and the RDRA was activated. The drone flew 16 kilometers at Mach 0.9 over 680 miles per hour using 80% of the RDRA's available thrust. The successful flight proved the viability of RDRA and the associated onboard flight systems. 3 weeks earlier, Venus Aerospace demonstrated the viability of its RDRA technology with a long-duration test burn, during which engineers showed their engine worked for the duration of this test flight. Rather than using a continuous burn like most rocket engines, RDRA operates by a detonation wave continuously rotating around an annulus or ring-shaped chamber. The fuel, hydrogen peroxide, is injected into the annulus and the repeated detonations become self-sustaining after the initial ignition. In the RDRA test flight, the annulus was approximately 25.4 centimeters in diameter and produced 544 kilograms of thrust. Venus Aerospace representative said in a statement the RDRA technology is 15% more efficient than conventional rocket engines. As a result, an RDRA propelled craft could theoretically travel farther on the same amount of fuel as conventional engines that combust fuel at constant pressure. Some have also theorized it could be as much as 25% more efficient than current technologies. The successful test flight raises the odds of commercially viable supersonic flight. One of the long-term goals for Venus Aerospace is to develop a commercial supersonic aircraft that could travel at Mach 9 over 11,000 km per hour. For comparison, the Concorde aircraft could fly at just over Mach 2, 2,500 km per hour, while the forthcoming Lockheed SR-72 prototype is expected to fly at speeds greater than Mach 6, approximately 7,400 km per hour. To put this into context, a vehicle flying at Mach 9 could travel from London to San Francisco in an hour. Just as Concorde was noisy at takeoff, the RS constant detonations will make any craft fitted with them incredibly loud. And unlike conventional jet engines, which offer much smoother accelerations, the rapid, repeated cycles of acceleration from the continuous detonations may also cause increased stress and fatigue of the engines and associated support structures. Because RDRA could have military applications, Venus Aerospace is also collaborating with DARPA agency. For now, Venus plans further test flights using drones. One test flight engineers are considering involves fitting the current RDRA on a larger drone capable of achieving hypersonic flight 5 times faster than the speed of sound, approximately 6,200 km per hour.
The second news with us says, do black holes hide the secrets of their ancestors? Black holes are monstrous and monolithic regions of space and time that have captured humanity's imagination. Some are created by the death and collapse of a massive star, yet no single star can birth the most tremendously large black holes. Those are the supermassive black holes that lurk at the hearts of galaxies with masses equivalent to millions or even billions of suns. Giant black holes such as these are believed to have been created when 2 smaller black holes collided and merged once upon a time. And now scientists wonder whether we can learn about the family tree of a black hole by working backward through the generations. If there is a cosmological object or event designed to be mysterious, it is the black hole. This region of space is marked by a boundary called the event horizon, the barrier between our universe and whatever lies within the void itself. Thus, it is impossible to get a signal and thus information from beyond this barrier. In addition to this, black holes have very few identifying characteristics. Black holes have no hair that means, unlike looking at a child's hair color or complexion and making a rough guess about the hair color and complexion of their parents. Hairless supermassive black holes seem to give away no hints at their lineage, or do they? Imre Bardos is a physicist at the University of Florida who theorizes that the limited characteristics of supermassive black holes, mass, spin, and electric charge, could actually hide details of the original black hole assembly line that created them. The standard picture of black hole birth that involves the death and collapse of massive stars can't account for the creation of the enormous black holes we see today. That includes both supermassive black holes as well as relatively smaller, intermediate mass black holes with masses around 100 to 100,000 times the mass of the Sun. Stars have sort of a limit of how big they can grow without basically falling apart by themselves. If a star gets very, very big, then it will explode before it has time to create this dense core that can form the seed for the black hole. We expect a natural limit for how heavy black holes can be when they form from the death of stars. This mass is something like 50 times the mass of our Sun. So it's a pretty large mass, but nowhere as large as a mass we see for supermassive or intermediate black holes. This means there has to be some other process creating the most monstrous black holes, and observations of tiny ripples in spacetime called gravitational waves suggest such a process could be subsequent collisions and mergers of progressively larger generations of black holes. How can we do the detective work to go back in the past and see what actually went down in the environment of merging black holes? Can we say anything about the black hole ancestors? The chain of mergers that would create a supermassive black hole is believed to take at least 1 billion years, but these cosmic titans have been observed in the universe since just a few 100 million years after the Big Bang. Those observations are courtesy of the James Webb Space Telescope. That leaves a challenge. Scientists still need to fully explain how these cosmic titans grew so big so quickly. However, maybe the clues lie in the ancestral mechanism itself. As gravitational wave detectors become more sensitive, humanity will spot these ripples in space and time from more distant and thus early black hole mergers. This means we should continue to learn more and more about how black hole growth has proceeded over the 13.8 billion year history of the cosmos. We're very excited about seeing things for the first time and discovering things going to the extremes of our knowledge. When we look at the extremes, things are very different from what we're used to, and black holes are extreme in many ways.
A last news with us says, nuclear fusion reactor in South Korea runs at 100 million degrees C for a record-breaking 48 seconds. Scientists have announced South Korea's artificial sun has set a new fusion record after superheating a plasma loop to 180 million degrees Fahrenheit, 100 million degrees Celsius for 48 seconds. The Korea superconducting tokamak advanced research reactor broke the previous world record of 31 seconds, which was set by the same reactor in 2021. The breakthrough is a small but impressive step on the long road to a source of near unlimited clean energy. Scientists have been trying to harness the power of nuclear fusion, the process by which stars burn, for more than 70 years. Fusing hydrogen atoms to make helium under extremely high pressures and temperatures. So-called main sequence stars convert matter into light and heat, generating enormous amounts of energy without producing greenhouse gases or long-lasting radioactive waste. But replicating the conditions found inside the hearts of stars is no simple task. The most common design for fusion reactors, the tokamak, works by superheating plasma and trapping it inside a donut-shaped reactor chamber with powerful magnetic fields. Keeping the turbulent and superheated coils of plasma in place long enough for nuclear fusion to happen, however, has been a painstaking process. Soviet scientist Natan Yavlinsky designed the first tokamak in 1958, but no one has ever managed to create a reactor that is able to put out more energy than it takes in. One of the main stumbling blocks has been how to handle a plasma that's hot enough to fuse. Fusion reactors require very high temperatures, many times hotter than the sun, because they have to operate at much lower pressures than where fusion naturally takes place inside the cores of stars. The core of the actual sun, for example, reaches temperatures of around 27 million F, but has pressures roughly equal to 340 billion times the air pressure at sea level on Earth. Cooking plasma to these temperatures is the relatively easy part, but finding a way to corral it so that it doesn't burn through the reactor without also ruining the fusion process is technically tricky. This is usually done either with lasers or magnetic fields. To extend their plasma's burning time from the previous record-breaking run, the scientists tweaked aspects of their reactor's design, including replacing carbon with tungsten to improve the efficiency of the tokamak's diverters, which extract heat and ash from the reactor. Despite being the first experiment run in the environment of the new tungsten divertors, thorough hardware testing and campaign preparation enabled us to achieve results surpassing those of previous KSTAR records in a short period. KSTAR scientists are aiming to push the reactor to sustained temperatures of 180 million F for 300 seconds by 2026. The record joins others made by competing fusion reactors around the world, including one by the U.S. government-funded National Ignition Facility, which sparked headlines after the reactor core briefly put out more energy than was put into it. Thank you very much for watching. Goodbye.